horizontal stretches and compression. So we know that x's are linear, so that b value, if you had a 6, tells you should multiply your x values by 1/6. But there's going to be a shortcut involved in this as well. So the question says determine the period, just like we did in question 1. We're also going to graph to see how the shortcut can help us with the graph. So in A, first of all, you have your regular coast graph. Whoops, almost. There we go. We have our regular coast graph memorized, that it goes as a period of 2 pi. Here's our axes family. Goes up to 1, down to -1. Has an amplitude of 1. There's our regular coast graph. Now, what does the 6 do? Right? We learned from our first unit that if that 6 is with the x, that would be a horizontal compression. You would multiply all of your x values by 1/6. Our shortcut looks like this. The period of cos is normally 2 pi. So what we do is we draw our axes like normal. But we take that 2 pi and say, if I multiply my x values by 1/6, then this 2 pi will get changed to 2 pi over 6. I could reduce that to pi over 3, but I'm just going to write 2 pi divided by 6 right now to really show that I just multiplied 2 pi by 1/6, and I got 2 pi over 6. Now, if we know that the full period got changed to 2 pi over 6, and normally in a coast graph you had 1, 2, 3, 4 equal sections, you take your new period and you divide it into 4 equal sections. And if you know that the full thing is 2 pi over 6, you can actually quite easily label the other ones without having to do all the mental math in between. I always start with the middle one. Does this make sense that this middle one is half of 2 pi over 6? And if I cut 2 pi over 6 in half, I get 1 pi over 6. And the first one would be half of 1 pi over 6. If I take half of this, 1 times pi, 2 times 6, I would get pi over 12. And then I always do the third one last, and I just actually count. If this one is 1 pi over 12, doesn't it make sense that 3 of them would be 3 pi over 12s? Which again could reduce to pi over 4, but that's another nice thing about the grade 12 pre-calculus. In grade 10 and grade 11, if you didn't reduce your fractions, you lost half a mark for not simplifying. In grade 12 pre-calculus, they assume you know how to do that. And so if you leave something like 3 pi over 12, you don't lose a half mark. You do not need to simplify fractions in grade 12, other than like in multiple choice questions, the answer will be simplified. So they assume you know how to do it. But in your own work, you could leave it like this. The amplitude, the A value is still 1, so we still have 1 and minus 1 as our max and our min. And then we use the pattern that a coast graph starts at a maximum. Then these 4 equal sections mean you go from maximum, center line, minimum, center line, maximum. And that allows us to graph things quickly. And because the period was 2 pi, on this graph, the period is 2 pi over 6 or pi over 3. We just took our normal one and found our new one. So we have shortcuts for these graphs based on what we know about the period. In B, we have tan of 2 pi over 3x. Y equals tan of 2 over 3x. So again, off to the side, I'm going to just quickly graph a little bit of tan of x. Tan of x has asymptotes at pi over 2, and going backwards would be negative pi over 2. Maybe I'll add one more. Right? Wherever on your pi plate tan was undefined, you have asymptotes tan of 0 is 0, and this is a bit of your tan graph. It keeps going and repeats itself over and over again. Right? The period of tan is pi, because how far is it between pi over 2 and pi over 2? That distance is pi. X's are liars. So when I'm going to graph in blue y equals tan of 2/3 x, this is a horizontal stretch, because you would multiply x by 3 over 2. And if the period was pi, and you stretched it, does it make sense that your new period is going to be 3 pi over 2? I just took my previous period, and now I've stretched it by multiplying by 3 over 2. It's going to be 3 pi over 2. As far as graphing goes, you're still going to have asymptotes, but now your asymptotes are in new places. What kind of new places are they going to be? Well, if we're multiplying by 3 over 2, does it make sense that this one is now at 3 pi over 4? I took pi over 2 and multiplied it by 3 over 2, which would mean the bottom would become 4, and the top 3 pi. If I multiply 3 pi over 2 by 3 over 2, I'm going to get 9 pi over 4. And here I would have negative 3 pi over 4. And as a result, I still have 0. I had pi. This point will now be 3 pi over 2, because I multiply by 3 over 2. So we're doing a lot of the same ideas that we had from our first unit on transformations. We're still doing stretches and compressions. When we get to C, you see how it has sine of x over 7? Are you okay if we write x over 7 as 1/7 x? By writing that out in front, you can see that this is a horizontal stretch. You would multiply x by 7 over 1, which is just 7. Think of your normal sine graph. So again, just like in our transformations unit, normal sine graph, start in the middle, amplitude of 1. So we have to have our normal sine graph memorized, quickly be able to draw it. It has a period of 2 pi. If you multiplied, right, this is y equals sine x, period is 2 pi. If you multiply your x's by 7, does it make sense that your new graph is going to have a period of 14 pi? The original period was 2 pi. We stretched it horizontally by multiplying everything by 7. But instead of having to multiply each individual point by 7, we use the following shortcut. We just label 14 pi as one period. Amplitude is still 1, so we can go from 1 to -1. divide this into 4 equal sections. Easiest to label the one in the middle first. What's half of 14? 7. Then easiest to label the first one. I actually like keeping it as a fraction. You could do 3.5 pi, but I like writing 7 pi over 2. Just cut it in half. And then I label the third one last, because if one of them is 7 pi over 2, does it make sense that 3 of them would be 21 pi over 2? I just took that 7 pi over 2 and multiplied by 3. Thinking of my regular sine graph. Where does a regular sine graph start? In the middle, going up. So now, I go to this, I start in the middle, going up, and then I would first ticky mark, get to a maximum, then center line, then minimum, then center line. And instead of having to do, you know, in chapter 3 we did like points and did arrows and said where they went and did lots of mental math, this is way quicker. Because you don't have to label any points. As long as your x-axis and your y-axis is labeled, and then you can just go for sine, center line to maximum, to center line, to minimum, to center line. Cosine would be start at a maximum, and then maximum, center line, minimum, center line, maximum. And since it's periodic, it'll just keep alternating like that. Okay. Circle of questions 3, C, and D. I think you already circled A and B. If you want, you can circle E and F already. We're going to have that for the next one.